We're moving on in our Algebra 1 skills review, and this is really going to be a two-part lesson. Both parts are going to be dealing with simplifying radicals. So let's just review this process of, as I've shown here, these problems, part number 1, A, B, and C. What does it mean to find a real number root? Well, letter A literally means that we're looking for a single number. I'm just going to call that number x for the time being. We're looking for a number that, according to this, it's a cube root, a number that would multiply by itself 3 times. Okay, cube root multiplies times itself 3 times, and that number, when multiplied by itself 3 times, would equal negative 1,000. So I hope that maybe after doing a little bit of thinking, and you really need to be able to do these without a calculator, that number would be negative 10. Negative 10 times negative 10 is positive 100, and then positive 100 times negative 10 is negative 1,000. All right, so now let's move on to letter B. If you're looking at a radical and there is no number, this is called the index. We usually call it the root. If the root is not showing, it's understood that there's a 2 there. It indicates a square root. So letter B means we're looking for a number when multiplied by itself, just 2 times, and we should get negative 81. Well, I'm hoping at this point you're thinking, how is that possible to multiply the same number times itself and end up being negative? You might think, well, what about negative 9? That's usually a common answer. Well, negative 9 times negative 9 is positive 81. So notice the directions say to find each real number root. Well, there is no real number root for this. There is no way to square a number and end up with a positive result. So you could either state, in this case, not possible or no real root. Okay, so let's move on to letter C. This says we're looking for a number multiplied 4 times, same number multiplied by itself 4 times, that equals 16. Well, that number would be 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so now let's move to simplifying radical expressions, and if you notice, now we're going to include some variables, and I want to show you an easy way to simplify variables under radicals. Okay, so once again, we're missing the index, so it's understood to be 2. So this indicates a square root. So the number that multiplies times itself 2 times to equal 9 is 3. Or in other words, the square root of 9 is 3. When it comes to variables, here's how you can simplify the variables. If you'll look at the exponent for the variable and divide by the index or the root, you will get the exponent for the simplified expression. So the square root of x to the 10th, just think exponent would be 10 divided by 2, which is 5. Okay, and that becomes the simplified form of that expression, that radical expression. Okay, so in a similar way, here's a cube root, the cube root of a cubed b cubed. So once again, let's take exponent and divide by index, and it's a to the 3 divided by 3 power. Well, 3 divided by 3 is just 1. So it's like a, or a to the first. And the same thing here. B, the cube root of b cubed, think b to the 3 divided by 3 power. And that's b to the first. So your simplified answer here is just ab. Okay, I think I got one more of these over here. So the 4th root of x to the 16. We'll think x to the 16 divided by 4 power, which would be x to the 4th. This is going to be y to the 4 divided by 4 power, or y to the 1st. So that's my simplified answer. Okay, so that pretty much wraps up part 1. There's actually two homework handouts, and you'll notice there's one called Handout 1 and then Handout 2. So on Handout 1, we're just going to practice these problems very much like the examples that I gave you in these notes. So now I'm going to jump into part 2. We're still dealing with radicals, but now we're just going to focus on multiplying. We're going to save dividing for a later lesson. So today I'm just wanting you to see how we simplify radicals, and we're going to utilize some multiplication. So there's a key point to remember when you're dealing with multiplying radicals. And instead of just reading this blue definition to you, I'll just try to paraphrase it. Two things have to be true about the radicals that we're about to multiply. If you notice, these indexes, they're both here identified as the letter N. Well, they have to match. Okay, a square root times a square root. A fourth root times another fourth root. If this is a cube root, meaning this would be 3, and this was a fifth root, this would be 5, then you can't multiply them together. Okay, so these indices, these roots, have to be the same. And not only that, but the radicals themselves have to be real numbers. So previously we looked at an example where we tried to do, I think it was the square root of negative 81, and we looked at why that's not possible. There is no real number root because it's not possible to multiply a single number times itself and get something negative. So the square root of negative 5 is not real. So therefore you cannot multiply these. You can't even multiply these and say that it's the square root of negative 25. If these two conditions aren't met, same index, and both radicals are real numbers, then you're just going to have to say this is not possible. You cannot do the multiplication because both radicals have to represent real numbers. Okay, so with that said, just a quick review of some terminology, because I run into people that get a little confused on how this is worded. This is probably familiar to most people. This means the square root of 16. And this is where we start running into trouble when it comes to cube roots, fourth root, fifth roots. I get some people that say the square root of the cube root of, and stuff like that. I guess just seeing a radical makes people automatically think square root. Well, the only time it's a square root is if there's no number present here in the index, and then it's understood to be 2. So notice how these are worded. If you were to ever have to say something in class or read something from a book, this is the cube root of 27, which is 3. The number multiplied times itself 3 times to equal 27 is 3. This reads as the fourth root of 16, and notice that's the number 2. 2 times itself 4 times. Here's a big one, the fifth root of 7,776. Well, the number 6 multiplied times itself 5 times would equal that number 7776. So I just wanted to review some terminology regarding radicals. And now let's jump into some homework examples. Your first 8 problems in the second handout look like this. Multiply if possible, and then simplify if possible. So here we have 2 radicals. They're both real. They're both square roots. So you can multiply them together. That would be the square root of 36, 3 times 12. And then we know that the square root of 36 is 6. So that would be my complete answer for letter A. Letter B, they're both the same root. They're cube roots. They're both real. And so I put these together, and I have the cube root of negative 64. Negative 16 times 4 is negative 64. And there is a number that would multiply times itself 3 times to equal negative 64, and that's negative 4. So let's think. Negative 4 times negative 4 is 16. And then 16 times negative 4 is negative 64. So we say the cube root of negative 64 is negative 4. Okay, a little problem here because remember for square roots, even numbered roots, It's not possible to multiply a number 2 times and get something negative. Anytime you multiply 2 negatives together, it has to be a positive. So since this is not real, then the directions say multiply if possible. Well, this one's not possible. Remember, the radical has to be a real number, both of them. This is definitely real, but this one is not. Okay, so now let's work on some problems like you're going to do 9 through 16. And these are a little more involved because the thing that makes these a little more challenging is we're trying to do the square root of a number that doesn't have a perfect square root, like 50. There is no perfect square root of 50. So the way I want to show you how to do these is we're going to make 2 radical groups that multiply together. Okay, and these 2 red radicals, when I'm done, should multiply to equal this given radical expression. So the trick is to use a number that does have a perfect square root that divides into 50 evenly. And I hope you're thinking, well, that's 25. 25 has a perfect square root, it's 5, and it also divides into 50 2 times. So the way I think about this is my left group, where I place 25, these are all perfect square root numbers and variables. They can be fully simplified. And then we're going to put the other leftovers over here in this right group. These cannot be simplified. So far I've made 50, the square root of 50, by using the square root of 25 and the square root of 2. Okay, so now do you remember from our previous lesson how do you simplify these radicals, or these variables under radicals? We said we try to divide the index, which in this case is 2, into the exponent. Well, the problem here is 2 doesn't go into 5 evenly, but it does go into 4 evenly. 2 divides into 4, obviously. So to make it equal to x to the 5th, when I multiply these together, I'm going to put x to the 1st over here. If you multiply variables like variables, you add the exponents together. 4 plus 1 is 5. Okay, so let's just do a double check. Do the 2 red radicals, 2 factors, multiply to equal this? 25 times 2 is 50. x4 times x1 is x5. Okay, so this left radical can fully simplify. The square root of 25 is 5, and the square root of x to the 4th is x to the 2nd, 4 divided by 2. And then this radical on the right, if you do it correctly, will never simplify. It's just going to stay radical. And so that ends up being my final answer, for example, letter A. Okay, for example B, the cube root numbers, the numbers that have perfect cube roots. Well, let's just make a little list. 2 to the 3rd is 8, or in other words, the cube root of 8 is 2. 3 to the 3rd is 27, or the cube root of 27 is 3. 4 to the 3rd is 64, or in other words, the cube root of 64 is 4. So 54 isn't in this list. It's not a perfect cube number, but I see a number that divides evenly into 54, and that's 27. So I'm going to write this as 2 radicals multiplied together, and they're both cube roots. Okay, I'm going to use 27 because it's perfect. I always call this the perfect radical, times the imperfect, or the rejects, or the leftovers, the number that would make 54 if I multiplied by 27 is 2. 27 times 2 is 54. Okay, so for n to the 8th, 3 obviously doesn't go into 8, but I'm going to choose the largest number less than 8 that 3 will divide into, and that's 6. So I'm going to make n to the 6th, which means to make it equal n to the 8, when I multiply, this is going to be n squared. Okay, so again, this left radical you should be able to fully simplify without a radical. The cube root of 27 is 3, and the cube root of n to the 6th is n to the 2nd. and then this right radical stays radical. Okay, letter C. The cube root of 80 n to the fifth. Well, once again, there is no cube root of 80, because if we keep going, we have the cube root of 125, which is 5. But I notice that there is a perfect cube number that divides into 80, and that's the number 8. So in my perfect cube root group, I'm going to put 8, and to make it equal to 80 when multiplied, this is going to have to be 10. All right, so for n to the fifth, the best I can do is put n to the third, because 3 does divide into 3, which means over here I'm going to have to put n to the second. So just do a check. When you're finished with your two radicals, do a quick check, multiply them together, and make sure that they equal the given problem, and they do. So this left radical, the cube root of 8, is 2. The cube root of n to the third is n to the first, 3 divided by 3. And then you just bring this other unsimplifiable radical down. And we're done. It may take a little practice, but these get a little bit easier the more you do them. Okay, so let's try this one. There is no perfect cube root of 18, and unfortunately none of these numbers that have perfect roots divide into 18. So for that reason, I'm going to put 18 over here in the non-simplifiable group, the reject group. As far as x to the fourth, I can put x to the third here because that's a perfect cube. 3 does divide into 3. So to make it equal x to the fourth, I'm going to put x to the first over here. So you simplify the left radical, that's just x to the first, and then the right radical stays in radical form. So my answer is x times the cube root of 18x. Okay, let's try this one. Square root. So there is no perfect square root for x, but 4 has a perfect square root, and it divides into 8. 4 divides into 8 2 times. All right, so 4 times 2 is 8. And then for x to the fifth, 2, this invisible 2, doesn't divide into 5 evenly, but I can do it like this. I can make it 4, which is divisible by 2. And then over here, to make it equal x to the fifth, I'll just include x to the first. So again, just do a quick glance. Do these two red radicals multiply to give you the black? They sure do. So simplify the left one. Square root of 4 is 2. The square root of x to the fourth is x squared. And then you bring down the radical that can't be simplified. 2x squared times the square root of 2x. Okay, this is just more of the same. We're going to multiply first, and then we'll simplify. So when I multiply these together first, I get the square root of 18 times 2, which is 36. X to the third times x to the second is x to the fifth, and then y to the third. Okay, so now let's work on simplifying using our two radicals as factors. Well, the square root of 36 is already a perfect square number, so I'm going to put it in the perfect group. X to the fifth, remember there's an invisible 2 here, so 2 doesn't divide into 5, so let's choose the largest exponent for x that can be divisible by 2, that's less than 5. That would be x to the fourth, and then this would be y to the second. Notice how each of these exponents are divisible by 2. And the leftovers, x to the first and y to the first, will go in the right radical. So the red radicals multiplied together equal this one up here at the top. And now you simplify the one on the right. The square root of 36 is 6. Square root of x to the fourth is x squared. The square root of y to the second is y. And then this right radical will stay radical. Okay, letter B, multiplying these together is the cube root of 40, x to the fourth, y to the fifth. Remember how we add the exponents together and there's an invisible 1 here. Okay, so 2 cube root factors. On the left one, we're going to put all perfect cubes. 8 is a perfect cube number, and to make 40, I'm going to have to multiply by 5. For x to the 4th, I'm going to put x to the 3rd because it is divisible by 3. So this is going to have to be x to the 1st to make x to the 4th. For y to the 5th, I'm going to do again y to the 3rd. It's divisible by 3. But to make it equal y to the 5th, when I multiply this, it's going to have to be y to the 2nd. Okay, and so my left radical simplifies fully. The cube root of 8 is 2. Cube root of x cubed is x. Cube root of y cubed is y. And then we'll just have to write this in radical form because it doesn't simplify. 2. All right, moving right along. I think this is our last example, so we'll multiply these together. This is the cube root of 8x cubed. So this one's nice because this is perfectly simplifiable. Cube root of 8 is 2, and the cube root of x to the 3rd is x. So this one did not have to be broken up into 2 different radicals. We could just simplify the single radical as it is. Okay, so I hope that gives you a good taste of the 1 through 22 problems. So this is actually labeled in RenWeb as 08 Homework Handout Part 2. Okay, and you're doing these problems. So the Part 1 I showed you earlier, I think it was 13 to 28. So again, there's 2 different handouts that you'll need to pull up. And if you didn't catch the Part 1 problems from the first video, or the first part of this, you can always rewind, but it's also listed for you on RenWeb. So I hope that helps you do the homework. And if you have any questions, please let me know.